This is footage for Hooke's Law. We have the red spring that's on there right now. There's a 50-gram hanger. It's not stretched out as of yet. It requires more mass for it to be stretched out, and I'm going to be putting in onto the hanger there 100 grams at a time, so that you can use this as a visual means to figure out what the behavior is of the spring as more force is applied downwards onto the spring by the masses. And again, with every mass that you put in, this is an additional 100 grams that's on this thing. So currently there's 50 grams on there. With each 100-gram mass, you're going to be adding another additional 100 grams onto this thing. This will bottom out at the bottom, at some point. But this should give you sufficient data for this set here for the red one to calculate what the spring constant or the elastic constant is for this particular spring. So without further ado, let's go ahead and do that. So right now, the bottom of the spring, which is measured to this point here, not down here, but this point here is roughly at about 50, we'll split it about 58.5 centimeters. So that's where our starting point is. We probably could have picked a better point for that, I think. Oh well.
You can't use the bottom here, no? Wouldn't it give you the same?
Yeah, I guess it would. So it doesn't matter. Yeah, you can use the bottom here. This is 75 centimeters, all right? So using that as your starting point there, your equilibrium position, we're gonna go ahead and put these on here. So 150 grams, it's dropped down a little bit, right? I'll leave that up to you to take your measurements. We won't say anything, all right? And now we increase it by another 100 grams, so now there's 250 grams on there. You take your measurements there for 250 grams or 0.250 kilograms. $350 grams or 0.350 kilograms. $450 grams or 0.450 kilograms. $550 grams or 0.550 kilograms. $650 grams or 0.650 kilograms. It's near the bottom there. It hasn't hit the bottom just yet, but it's almost about a centimeter off from the floor, the tabletop there. This is 750 grams or 0.750 kilograms on the spring here. All right, so that should be enough for you to calculate what the spring constant is for the system. Again, using your equilibrium position where you started off, subtract off how much it is stretched out from there to use that as your displacement, all right, for the measurements here. And then using that, you can plot this against the restoring force associated with the hanging mass and the acceleration due to gravity. So you should be able to calculate the force associated with each of the masses that we attach to the system, and then plot that, get a linear plot, and then you can use the slope of that to get the elastic constant or spring constant in this case. All right.